In this section, we're using proportions some more. We just did some work with pictures. So we had a trapezoid or a triangle set up, and we could find some missing measurements from that. We're going to be looking at using proportions to, and using that same idea of a similar figure to do some indirect measurements. This would be if you were trying to measure the height of a building or a mountain or something. It would not work well to try and use a tape measure to measure how tall a mountain is. Mostly because you don't have to draw this or anything, but if you have, there's a mountain right there, there's a snowy peak on the mountain. The height of the mountain is not how long the side is. That's not the height of the mountain. The height of the mountain is from the center up through to the top of the mountain. It's very difficult to figure out exactly where the center of the mountain is, and then to measure straight up and down, you can't really use a tape measure. So we have to come up with other ways. We have to be creative in ways that we measure these things that are just it's not able or not practical to directly measure them with a ruler or a tape measure. So we use these indirect measurements. And we're going to look at some examples. We're also going to do a lot of pictures. We're going to draw a lot of pictures. On your test, in bold, it's going to say, you must draw a picture. I am going to give points based on whether you draw a picture or not. Now, you'll find that your pictures do not have to be good. I'm not going to grade artistic ability. However, the picture must be there. So a flagpole casts a shadow that's 75 feet long at the same time as a 6-foot-tall man. So here's my flagpole. There you go. That's all you have to draw for a flagpole. So I don't want to hear anybody complaining, why do I have to draw a picture? Just draw a flagpole. All right, so we got a flagpole, and it casts a shadow. All right, there's the shadow of the flagpole. That is 75 feet long. So there's my 75-foot shadow. At the same time, a 6-foot-tall man. All right, so there's my 6-foot-tall man. And if you want to be more artistic than me, by all means, please do. So I've got my 6-foot-tall man. I'm going to label it 6 feet. And really, the most important part about these pictures is labeling them. So we've got a 6-foot-tall man casts a shadow that is 9 feet long. All right, so there's the shadow, and it's 9 feet long. And there's my shadow. I've got my pictures. It says, write and solve a proportion to find the height of the flagpole. So I don't know the height of the flagpole in X feet. So I got to figure that out. This looks oddly like 2 triangles. And if the sun was at the exact same point in the sky for both of them, they'd be similar triangles. We know a lot about similar triangles. We can set up proportions based on these similar triangles because similar figures are proportional. All right. So I can find my corresponding sides. So I've got the height of the flagpole matches or corresponds with the height of the person. I read from left to right, so I'm going to put x over 6. But you can certainly read from right to left and do 6 over x. That's fine. And then I'm going to compare the shadow to shadow, height to height, shadow to shadow. So I'm comparing things. And so I've got 75 feet and I've got 9 feet. So I made some comparisons. And again, I said in class there are like 12 ways to do this correctly. This is just one way to set it up correctly. But I compared the height to the height. I compared the shadow to the shadow. And I was consistent. I went from right to left. Now I can cross multiply and divide. So I'm going to cross multiply 6 times 75. Let's see, 6 times 70 would be 420. 6 times 5 is 30. So 6 times 75, 450 equals 9x. And that works out pretty well because when I divide by 9, I should end up with 50 equals x. And I have to label that. That's going to be 50 feet because there's a difference between feet and inches. So 50 feet equals x. And let me just double check. Does that make sense for x? So if the guy was 6 feet tall and his shadow was 9 feet, his shadow is longer than his height. If the flagpole is 50 feet tall and the shadow is 75 feet, yep, shadow's longer than the height. That makes sense. So I've got my answer, 50 feet. So for these problems, draw a picture. I do require that you draw a picture. You're going to draw pictures in your homework. You're going to draw pictures on the test. Practice drawing a picture, even if it's a bad picture. Set up a proportion. See which sides correspond, height to height, shadow to shadow. And then cross multiply and divide to get our answer. Try this one on your own. A forest ranger is in a tall, forest ranger who's 150 feet tall, so that's a person, 150 centimeters tall, that casts a shadow. We got a tree that has a shadow. Figure out how tall the tree is. And again, your tree does not have to be good. So, there's my tree. It doesn't have to be a very pretty tree. And then draw a person. So there's your forest ranger. Okay, so pause it, try this one, see if you figure out the answer. I'm assuming you tried it. I'm assuming you paused it and tried that, drew some pictures, labeled your pictures, set up a proportion, found the answer. The correct answer for this one is that the tree, what was it? Height of the tree. The height of the tree is 650 centimeters tall, which seems tall, but a centimeter is pretty tiny. So 650 centimeters tall. If you didn't get that answer, make sure you watch the linked video. Next one. Again, I want you to try this on your own. But a woman and a building. Okay, so I've got a woman. There we go. Okay, and I've got a building. Done. You can be more artistic. You can put windows and shading and put little flowers on the windowsills or something. I don't care. But draw a picture of a woman, draw a picture of a building, and see if you can figure out how tall the building is. I'm assuming you paused it. I'm assuming you tried it on your own. Again, if you didn't do the work, don't just wait for me to give you the answer. That's not learning. And the correct answer for this one is that the height of the building is 44 feet tall. 44 feet is the correct answer for this one. If you didn't get that answer, watch the linked video and see how it's set up. Last one here, a hummingbird can fly at 15 meters per second. We don't know how many miles per hour this is. So this is what we've been doing in class with those conversion rates. This is not a proportion. All right, so I want to emphasize that again. This should not be a proportion. This is where we have a fraction, where we know where we're starting. We know where we want to get to. How do we get from 15 meters per second to however many miles per hour? So pause it. Give this a try. I did let you know how many meters there were in a mile because I don't expect you to know that off the top of your head. But see if you can figure this one out. I'm assuming you paused it. I'm assuming you tried it on your own. This is something that will be on the test, and so we want to keep practicing this. So don't just brush it off as, oh, I can't do it. Practice it. The correct answer for this one is that they go a total of 33.6 miles per hour. So m miles per hour. So that's how fast they go. If you didn't get 33.6 miles per hour, watch the linked video and see how that one's done to keep practicing it.